In this class, we are going to discuss about some of the sensors using in robotics. Before going for the detailed discussion about different types of sensors using in robotics, we can look what is the use of a sensor. A sensor senses or measures a physical quantity and convert it into a signal that can be read by an observer or an electronic device. Pressure gauge is a typical example for sensor which can be read by an observer. We can directly read the pressure value from the dial. Thermocouple is a typical example for sensor which can be read with the help of an electronic device. Next, we can look what is the need for sensor in robotics. The sensor on a robot give them sensing capability, which means that the sensor can extract information from its surrounding and then behave based on the information it extract from the surrounding. Because of this added capability, the robot can work in a more autonomous manner. And also this will increase the performance of a robot to the next level. Now we can look in which all ways sensor helps the robot. Mainly the sensor help the robot in first one localization, obstacle detection and to collect internal information. Now we can look each one by one. First, what's meant by localization? Localization is a process in which the robot get an information about its working environment or the place where it's deployed for operation. So a simple example we can see what is really localization means. Now consider a robot and a target. Assume that the robot is a wheeled robot. That means a robot which can roll on the ground. Now the current location of the robot is XY, and the robot need to move from the current location to X final, Y final where the target is located. Now for the robot to fix its current location and the target location, that means for the robot to find the XY value and XF value, the robot needs to know its working boundary and also all the obstacles and all the hindrance exist in this particular boundary or the workspace. So based on that one, the robot will generate its coordinate and the path from the current location to the target location. Now the second one, obstacle detection. Now consider an industrial robot is deployed for some work in an industry, and the robot is in the working cycle without knowing that the operator of the robot approaching the robot. Assume that the man is moving along the working region of the robot. So to save this person, the robot need to identify some foreign objects are entered in his working environment, and then either the robot stops there or deviate from its predefined target. So this process we called as obstacle detection. Now we can look at another example. An industrial robot wants to pick an object from one place and place it on the small table, but in the environment, the working environment or the workspace, and the table is also there. So when the robot pick the object from its current location and place it on the target location, the obstacle need to be avoided so that collision between the robot and obstacle can be avoided. So for that particular purpose also we use certain type of sensors. Next is to collect internal information. Again consider a tooling planar manipulator. For the manipulator to move in its workspace, we need to fix motors or prime movers to the joints. Usually stepper motor, DC motor, pneumatic drives or hydraulic drives are used as the drives in the joints. So here I mentioned earlier about the stepper and DC motor. Now to control the robot, we need to know how much angle this motor rotates. So to get that information, we need to add certain sensors to these charts. Also for control application, we need to know how much torque is developed in these joints. So we need to add some torque sensors to these joints. So force sensor, torque sensor, displacement sensor, etc. as typical example for internal information collection sensors in robotics. Now in the gripper also we usually add a sensor to get an information how much the gripper move or how much force the gripper exert on a surface when it pick the object. So that sensor also we can call as a internal information collection sensor. The next is the important types of sensors using in robotics. The first one is proximity sensor, which is a non-contact sensor. The second one is touch sensor, which sends the touch on a surface. The third one is press sensor, which is attached to the end effector to measure the force and torque act on the end effector when it hold an object. The fourth one is slip sensor. Again, this sensor is also attached to the internal surface of the gripper, and the object is to measure the slippage when the gripper hold a particular object, and this will prevent the accidental falling of object from the gripper. And the fifth one is position sensor. Sixth one is range sensor. So in this class we are mainly concentrated on proximity sensor, and in the coming classes we will discuss all other type of sensor. Three main classification or the three main important types of proximity sensors are inductive proximity sensor, capacitive proximity sensor, and ultrasonic sensor. So before going to detail about the different types of proximity sensors using in robotics, we can look what is a proximity sensor. The figure gives a schematic representation of a proximity sensor. The proximity sensor is an active phase. So this active phase sends the presence or absence of the target. Usually the sensing mechanism is placed very close to this active phase. One of the important parameter of proximity sensor is sensing distance. The sensing distance of a particular proximity sensor depend on the type of target. Usually we calibrated this sensing distance and accordingly we fix the sensor in a particular application. Proximity sensor is usually called as a digital sensor because it give only output information, only about whether the object is close to the sensor or far away from the sensor. It never give any information how far away from the sensor, which means that it never measure the distance. That's why these proximity sensors are usually called as digital sensor. If the object is within the sensing distance, the proximity sensor gives out a digital output, which means that the object is sensed. But on the other hand, the object is away from the sensing distance, the proximity sensor will not give any output, which means that the object is away from the sensor. Proximity sensor can sense both metallic and non-metallic objects, including liquids. Next is capacity proximity sensor. Capacity proximity sensor can sense both metallic and non-metallic objects, including liquid. Usually these capacity proximity sensors are used to measure the level of liquid in bottles in automated bottle filling industries. So in the capacity proximity sensor, an active capacity plate is there, which is connected to a oscillator circuit. The target acts as the second plate for the capacitor. When the target is away from the active plate of the sensor, the oscillator produces a very high frequency signal. But when the target approaches the active phase, the spacing between the plate decreases or the capacitance increases, and which cause a decrease in frequency of from the oscillator circuit. The oscillator in the circuit generate high frequency and low frequency output based on the position of the target. So when the target is closer to the active plate, the oscillator circuit generates a low frequency signal. The frequency detector continuously detects the frequency of the oscillator and put it to the control circuit. The control circuit is having a particular threshold frequency value. If the output from the frequency detector is lower than the threshold frequency value or in that particular limit, the sensor give an information that the object is closer to the sensor. Here analog to digital converter is used to make the frequency information in digital format. This capacity proximity sensor is widely used in automation industry. The next one is inductive proximity sensor. The, the inductive proximity sensor looks similar to the capacity proximity sensor. Here the only difference is in the place of active plate of capacitor, induction coil is placed. The remaining circuit or the remaining components are same for the inductive capacity proximity sensor. The main difference of a inductive sensor from a capacity sensor is inductive proximity sensor sends only metal targets, whereas the capacity can sense both metals and non-metals. Here also the system used the change in frequency concept to sense the object. Here the working principle is when the target is closer to the active phase or close to the coil, an eddy current is generated in the metal target. This eddy current induced a back EMF in the coil which cause load on the oscillator. So load on the oscillator means the oscillator starts to generate low frequency signal. The frequency detector continuously sends the frequency out from the oscillator, and if the frequency from the oscillator is lower than a particular threshold value, then the control unit come to the conclusion that an object is closer to the proximity sensor and give out an output. Similar to the capacity proximity sensor, the inductive proximity sensor also having a target distance between the detector and the target. If the target is within that sensing distance, then only the sensor sends the object. The target distance is a function of type of metal. For different metals, different target distance. You can obtain that information from the datasheet of that particular inductive proximity sensor. The inductive proximity sensor is widely used to detect ferrous target. The two violet color rectangular blocks on the sensor indicate two nuts which can be used to fix the sensor to the intended location. Next one is ultrasonic sensor. The main difference of this ultrasonic sensor over the other two proximity sensors, that's capacity and inductive sensor, is ultrasonic sensor not only sense the presence or absence of the target, but also it will give an information how far the object is away from the sensor. And the second advantage of ultrasonic sensor is its range or the sensing distance is much higher than that of the proximity, other two type of proximity sensor. That means capacity sensor and inductive sensor. Usually the sensing distance of capacity sensor and inductive sensor may be say 10 to 15 less than 15 centimeters, but for the ultrasonic sensor this may be say 30 or 40 centimeters. Ultrasonic works similar to the radar. The ultrasonic sensor is having two units, an emitter unit and a detector unit. The emitter unit emits high frequency sound waves, usually in the frequency range of 25 to 50 kilohertz. The emitter and detector are kept at certain distance apart. Usually it's represented by 2h distance, and the target is at a distance x away from the sensor. Always the x distance is much greater than that of 2h. So we can approximate the distance calculation formula. The emitter emits ultrasound waves, get reflected on the target and come back to the detector. Now in the ultrasound sensor, we can measure the time taken for the sound to travel from emitter to target and come back to the detector. We know that time value and the speed of the sound wave, we can easily calculate the distance between the target and the ultrasonic sensor. The x value we can calculate it as x will be equal to c, the velocity of sound, multiplied by time taken for the complete travel of the sound by 2, because emitter to target distance and target to detector distance is approximately equal. So time taken for the sound to travel from target to detector is total time divided by 2. So the x value we can calculate it as x equal to ct by 2. T value we know, c is the velocity of sound, it's a constant in a particular medium. Usually it's happened in the atmospheric condition, so we can take it as 320 meters per second. We can easily calculate the x distance.